Antlions are insects. In their adult form, they sort of look, in my personal opinion, like a less cool version of a dragonfly. They are not a dragonfly. But in their larva stage, they look, well, not like many things I can compare it to. They have these mandibles and they make these sand pit traps. And then they wait with their mandibles just showing above the surface. When an ant or other small insect walks over their sandpit, they drag it in. They pull the ant underground, biting it and injecting it with enzymes to digest it in order to consume the ant's juices. I also have learned by watching them that they toss sand at their ant victim too if they need help subduing it before they drag them under. Thankfully, antlions are small. In fact, doodlebug is evidently another name for these things. I'm not exactly sure how you go from antlion to doodlebug, but okay. It's all relative. They're bad news for an ant because the antlion is a predator of the ant. The ant is their prey. That's an ecological relationship right there. And that's what we're going to talk about, ecological relationships. Typically, if we were to graph the predator and prey populations in our example, when the population of ants in this confined area increase, it is likely that the antlions, which are the predators, also will increase over time because they have more food to eat. However,
thing getting eaten. Okay, the predator is the thing doing the eating. How are these two related? Yeah, good, right? So yeah, the prey gets eaten, right? So if you have a high prey population, the predator population kind of mirrors it, right? It doesn't respond right away, but it makes sense, right? You have more prey available, and then the predator can eat those. Not all ecological relationships are like this, but pretty much all of them. So that first question I think asks about how it's related. More prey is good for predators, right? And as the predator population goes up, that's usually actually not great for, so they are kind of correlated, right? In that when you have more prey, that's good for predators. When you have more predators, okay, that's not great for prey, but as the predators start to starve, right, when this bottoms out, then you kind of get this cycle, okay? So
if the antlions increase too much, there won't be enough ants, which are the prey, to feed on. So the antlions will decrease. You can see that relationship in this predator and prey graph. In most ecosystems, predator and prey graphs go up and down frequently. It cycles. Also, just because this antlion is a predator doesn't mean that this is the only role it plays. An antlion can get eaten by a bird. Now the antlion has just become the bird's prey. Competition is also another relationship to consider. Antlions are consumers, which means they have to eat other things. They can't make their own food. They have to compete with other antlions for this food too. This food being their prey, the ants. This example shows competition for a limiting biotic factor. And they're not just competing with other antlions for this biotic factor, they may have to compete with completely different species in the area that are also predators of ants too. For example, jumping spiders like ants. It's not just consumers that compete. Producers, like this plant, make their own food, but that does not mean they don't have to deal with competition. For example, this plant here is competing for this limiting abiotic factor, light. Symbiotic relationships are specific types of relationships where different species live together. Parasitism is an example of a symbiotic relationship where one organism benefits and the other is harmed. An example? Well, I love dogs. Petunia is the cat person. When my family took in our rescue dog, she was 4 months old at the time. We learned from the vet that she would need to be treated for fleas and hookworms. We were able to give her medicine to treat these parasites. A good thing because these parasites can hurt the dog by feeding on their blood. A parasite is an organism that gets its nutrients from another organism and causes harm to its host. They can live inside or on their host. Mutualism is an example of a symbiotic relationship where both organisms involved benefit. You really need to look up a video about acacia ants and acacia trees because this is a fascinating example. See, some species of acacia trees form these hollow thorns which provide housing to acacia ants. Some species even provide a nectar for food for these ants. So, what does this tree get in return? Protection. I'd hate to be a type of consumer that eats acacia trees because if it has acacia ants, the ants will come out of the thorns and attack the consumer. They'll even destroy plants that try to grow close to the acacia tree so the ants can eliminate the tree's competition. Nice mutual relationship between the acacia tree and the acacia ant. The last symbiotic relationship we'll mention is commensalism. This one is interesting because in this relationship, one organism benefits and the other is neither helped nor harmed. It has a neutral effect. Some species of barnacles and whales are a great example. Many barnacle species can attach themselves to moving things, like a boat or a whale. On a free whale ride, the barnacles get a lot of access to food since they are filter feeders and the whale may travel to nutrient rich waters. In this particular example, the barnacles benefit, but neither help nor harm the whale, so this would be commensalism. But I do like to remind my students that sometimes there's more to the story with a relationship labeled as commensalism, and sometimes what we thought was a completely neutral effect may not always be in every case. So, why do all these relationships matter anyway? Well, one reason is that these interactions can make significant impacts on populations of different species living together. That means if the population of a certain species is threatened by human activity, for example, it can affect more than just that one species. Scientists continue to learn about new ecological relationships all the time. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.
covered if I went through it like in depth, but limiting factors is that one. So again, just be careful when you are looking at the two y-axes. And we'll go through this one quick. So I'll give you a little bit of time for that. And then we also have one thing on the symbiotic relationships. So like mutualism versus commensalism versus parasitism. And then we're going to look briefly at competition. But we should be able to get all that done. You won't have any homework or anything, and then that'll be it. Okay, so start with that one. And I'll pass out something else, then we should be good. I'll pop back on here and go through it. sorry, virtual folks. I was just gonna, if you're watching the recording, I know none of you are on there right now. So population of links, as a reminder, a lot of you will look at this, see this one, okay? But you actually have to look at the y-axis that is focused on the links numbers, okay, which is right around 4,000, right? 4 times 10 to the power of 3, okay, right around this point. So whenever you see a graph with 2 y-axes, I should say, okay, you always have to make sure you look at the header. Again, I always like to look over at the left side one because that's most graphs out there, but you always have to pay attention. So let's see what else we got. Approximate. Hair population's good. Links population, okay, that one's pretty good. I guess these are on the whole actually pretty good. Yeah, let's talk about these. Okay, so let's talk about propose an explanation for the apparent cause and effect relationship between the populations of hares and lynx. So we've got a couple of them here. Presence of other predators, disease, availability of food-like resources, weather, such as flood or drought, availability of shelter, and competition. The ones that it would be a relationship between the predator-prey are all 3 of these, right? So the idea that the hare is the food source for the lynx, okay? So the population of the lynx and the hare are directly correlated with one another, right? These are all external factors, but these 3 are directly related to that predator-prey relationship. And then all of these factors are what we would call limiting factors, okay? So a couple definitions, the reason why I wanted to poll virtual folks here and wanted you to kind of fill it out is I've got a couple definitions on the board, okay? Limiting factors are anything that controls the population size of a species. I would have that definition just at the ready, because when we talk about our Daphnia population, some of you might be a little bit disappointed that we're doing really well. That'll be just my hint, okay? If you're doing really well in your Daphnia population up to this point, was doing really strong, maybe you hit your carrying capacity. And carrying capacity, I'll also throw a definition up there of that, okay? That is the number of organisms, we'll say within a population. So like if we're talking about our Daphnia population, for example, and virtual folks, I will throw these definitions up on the board. I'll also turn the sharing camera off thing once I get there, so that you can do it. But as the number of organisms within a population that an area can support. Okay. Now, by area, I usually mean like some sort of ecosystem or habitat. So for example, we made a mini ecosystem with our Daphnia. Okay, we made a habitat. So our carrying capacity, some of you who had an ideal system, you will probably hit a point where you've reached your carrying capacity. But the key thing that determines carrying capacity is limiting factors. Okay, so toss those definitions in, and then go ahead and you can work on those second pages if you're good. We did pretty well on Google Forms. There's a bunch I have to say. But those are all examples of things that would control a population and determine limiting factors. So limiting factors determine a population's carrying capacity. And for each of those pages, each of those is like a checkpoint, so let's take a look at it. Kind of touch it. Oh, you're right. Yes, the tapeworm one should start where it says tapeworm. Yeah, it should start right here. Right. Not sure how that happened. This was originally. Yeah, that's good. Yep. This one was kind of confusing there because you wouldn't think of I'm sorry, eating algae as usual with them, but like algae are just an acid, it's not organisms, so it doesn't die. It's actually relatively unaffected. Yeah,
Can we
so.
show you all our pages?
Yes, once you get, the first page done, like front and back, you can show it to me.
All up, can you come
And I'll check it off quick just to make sure you got it. And then, I'll just put in an overall completion grade for all these checkpoints.
Literally, I get to do it to start the relationship and then it's. Yeah. About third session. Right? Oh, okay, right.
Well, you don't agree?
I don't agree. It's about these two.
Okay, so these both, which one do you have? Both. Okay, so let's talk about it. So 15, why do you think we do? What led you to do?
Yeah, it was like, the name doesn't mean it. No, it says, right?
So they are going to get rich. That's true. This one, though, so both of these represent two populations. This one, they both do pretty well, right? Whereas this one, one, right, and one did. So this one is a clear example.
I did.
C, on the other hand, though, is
All three. So there's still.
yeah, all of this species, all of that. You're right. They're all examples of competition. B and C are examples of competition. So technically, this one could be. We're gonna toss these. These are serving the purpose. I wish they had a little better, but they serve the purpose.
The one that you said, I don't know.
We are, yep, I'll take a look at them.
But I'll have this answer, but I don't know if we got this one. Look, it's like on the graph, do you see? I don't know.
It's not an organism.
Okay, but you have that and she has real one.
Cool.
Where did you go? Oh my God, there is this
Check our day on the same page. You want.
Can I go bring this to Miss One? Can I go bring this to Miss One?
Sure. Oh, wow, what you want?
What is it?
He does?
Who does?
This is who calls.
Okay, that's what we're into enough. She loves me like her love. Allie does her love. Yeah.
There's a giant spider around.
Can I go quickly? Quickly. No mess. I'll be quick. That's so weird.
That is so strange. So bizarre. All right. How's it going?
Give her a fight.
I know.
She doesn't look like. Why would you? We can have a quiz on this,
Yeah, so we won't have a quiz on it, but all this marks the end. That you're doing right there with the checkpoints marks the end of the end of our material knowledge file. That'll be it. I mean, we'll do the gap in the lab, we'll finish up, put it directly related to the capacity, all these snaps, so. Yeah, once you finish that, you have officially, completed the. To be fair, I didn't know she actually had a. You can also.
Oh, I was just thinking, because like.
Yeah, because they separate these two, like, they're both kind of, maybe they don't have compete. So your B's the better. You can do either one, but that's good.
Gave me money.